video, we will show you how to build AND, OR, and NOT logic gates using a breadboard, ICs, and LEDs. This demonstration helps you see how these gates process inputs to produce outputs. Logic gates are the foundation of digital electronics and computers, making them essential for understanding modern technology.
Now, here are the materials used in the logic gate demonstration along with their specific functions and purposes in making the circuit work. Breadboard, a tool used to build and test the logic gate circuit without soldering. It allows all components, ICs, LEDs, and wires to be easily connected. 7408 AND Gate IC, an integrated circuit that provides AND logic gates. In the demo, it shows that the output LED lights up only when both inputs are high. 7432 OR Gate IC, an IC containing OR logic gates. It demonstrates that the output LED turns on when at least one input is high. 7404 NOT Gate IC, an IC with inverter NOT gates. It is used to show how a high input becomes a low output and vice versa. LED, a small indicator light that shows the output of each logic gate. It lights up when the gate's output is high. 220 OHM resistors, used to limit current going to the LEDs, protecting them from burning out during the logic gate demonstration. Jumper wires, flexible wires used to connect inputs, outputs, power, and ground on the breadboard to form the logic gate circuits. Power supply 9V battery, the main power source that provides voltage to the logic ICs and allows the entire logic gate demo circuit to function.
The process for the NOT gate wiring is similar to the AND OR gate setup, but the IC must be replaced. I swap the current IC with a 7404. Then I adjust the black and green jumper wires. The green jumper wire was moved down and the black jumper wire was moved to the right, replacing the white jumper wire's original position. The white jumper wire was removed as it was no longer needed for this process. The wires were moved and removed to test all the input conditions, low and high, of the OR gate and verify its correct logic function. Based on the truth table, 0 input equals 1 output. 1 output equals 0 output. The circuit is demonstrating the function of a NOT gate. As you can see on the video, that in this setup, when the IC's input is connected to the negative rail, logic 0, its output goes high, causing the LED to light up. Conversely, when the input is connected to the positive rail, logic 1, the IC output goes low, which makes the LED turn off. Therefore, the LED's illumination pattern precisely follows the inverse logic characteristic of a NOT gate.
The AND gate and the OR gate follows the same process because both of them use the same basic setups and components, such as the breadboard, the IC, the power supplies, and the LED pins. The wiring steps are most likely identical. You place the IC to the breadboard, connect the power supplies to the correct pins, and connect the LEDs to the correct output pins. The only real difference between them is the type of logic that the IC performs internally. In an AND gate, the output is high only when both of the outputs are high, while on OR gate, the output is high only when one of the output is high. Even though their logic behavior is different, the wiring process is basically the same. which is why, in assembling the steps for both gates are totally identical. And with that, we're going to change the circuits to the 7408 to create the AND gate. In the third table, there are four possible combinations of the two input A and B. On the row 1, which is the 0, 0, neither of the input is 1, so it means that the output will be 0. In the row 2, which is the 0, 1, the input A is 0. So the conditions of all the inputs being 1 is not met. So still, the output will be 0. Then, in the row 3, which is the 1, 0, now the input B is the one who's 0. So it means the conditions of all the input being 1 is not still met. So still, the output will be still 0. In the final combination, in the row 4, both inputs are now 1. It satisfies the condition, so the output is now 1. So, in a simple term, an AND gate is like an electronic switch that only ons when all the inputs met the requirements simultaneously.
To build the circuit, the process starts by inserting the IC 7432 into the breadboard. The IC is oriented so its notch or dot is on the left, indicating pin 1. Next, the green wire is connected from an input pin 1 to the ground power rail. A white wire is connected from the second input pin to the VCC 5 volts power rail. And the first blue wire, the one opposite to the green wire, connected to pin 4 is also connected to the VCC rail to power the chip. The second blue wire connects to the IC grounds pin 7 to the ground rail. For the output, a black wire is connected from the output pin to one leg of the red LED. A 220 ohms resistor is connected in series with the other leg of the LED, and the resistor's other end connects back to the ground rail to limit the current. Finally, the two orange wires are used to bridge the BCC and GND power rails across the board. The circuit is completed when the main blue and white wires are connected to the external power source, with the blue wire going to the BCC and the white wire going to the GND, which will power the circuit and potentially light up the LED based on the OR gate's logics. If any input is high, the output will be high, lighting the LED. And this is the video demonstration of OR gate. This is the truth table of OR gate. Row 1, input A 0, input B 0. Both inputs are low, so the output is low. Row 2, input A is 0, input B is 1. The input A is low and the input B is high, so the output is high. Row 3, input A is 1, input B 0. Input A is high and the input B is low, so the output is high. Row 4, input A is 1, input B is 1. Both inputs are high, so the output is high.